Hello everybody, we will talk today about buck converters and their basic circuit. Buck converters are used to step down the voltage from particular level, for example 12 volt or 24 volt DC, to other levels which is like maybe 5 volt or 3.3 volt. You may need this converter to convert 12 volt battery voltage to 5 volt to power an Arduino or a big microcontroller. So let's see how it works and what is the basic principle for this circuit. Now we have to know the components in this circuit. We have a battery, 12 volt battery. We have a switch. We will manually switch this one to produce the on and off time. We have an inductor, a capacitor, a diode, and we also have a load. And the load is consisting of a lead and a limiting resistor, 330 ohm, in parallel with 1 kilo ohm. The load can be anything. So now to understand the working principle for this circuit, let's just start by adding the elements gradually and see what happens after adding each element. We will remove the inductor, the capacitor, the diode at the beginning, and we will just switch the input voltage to the load and see what happens. So if we operate the circuit and look at the output, now you will see the battery voltage in green, 12 volt. The output voltage is 0 volt in red, and the voltage after the switch is in blue. And we will start switching this switch on and off, on and off, and you will see that the voltage will reach the load as it is. So the load will see a 12 volt, then a 0 volt, a 12 volt, and a 0 volt, depending on the on and off state of the switch. So we didn't actually achieve anything. So to achieve what we need, we will add an inductor to the circuit. So let's remove the capacitor and let's remove the diode. We will just add an inductor in this stage, and we will see that the inductor will limit the voltage reaching the load, because the inductor is an electrical element which always resists any change in the current. Inductors doesn't love the current to change suddenly, so the inductor will always try to oppose the power supply to make the current rise gradually. So if we start switching the circuit after adding the inductor, you will see that when switching on, the current will rise gradually, and when switching off, the voltage will go down to 0, but the current will not go down to 0 suddenly. So you will see now that the voltage in red is less than 12 volt. It doesn't reach 12 volt, and we can just make it more or less than 12 volt by changing the on and off time. So how does the inductor reduce the output voltage? Actually, when we switch the circuit on, the current start rising in the inductor, but because the inductor doesn't like the current to change suddenly, the inductor will produce terminal voltage opposing or opposite to the battery voltage, and will resist the current flow. So the output voltage seen by the load will be less than 12 volt, because it is 12 volt minus the voltage developed on the inductor. While the inductor is working on the on state, the inductor will store energy as a magnetic field, and it will supply this energy back when the switch is off. So let's see what happens when we close the switch. Actually, when we close the switch, the current will rise slowly in the inductor, as you see here. And to understand what happens here, we will see that after closing the switch, there will be a current flowing in the circuit. So this current will start to rise. The inductor will resist this current to flow because the initial current in the inductor was 0. So the inductor will develop a positive negative voltage. This is VL, and this voltage, if you notice, it is opposite to the source voltage, so it will reduce the output voltage here. So V output will be Vn minus VL. So V output will be always less than the input voltage. But now if we open the switch, let's see when we open the switch. When we open the switch, the current will go to 0 because the physical connection is forced to be open. You will notice that the inductor current will go to 0, and there will be a big spike of negative voltage on the supply. That's because we forced the current to go to 0, and the inductor will develop a very big voltage difference between its terminal to maintain this current to flow, and this is the cause of the voltage spike. Let's see what happens. Now when the switch is open, there was some current flowing here, but suddenly we open the switch and the current will fall to 0. Inductors doesn't love the current to fall or change suddenly, so the inductor, to maintain the current, will produce a very high voltage between its terminal. It will reverse its terminal, plus minus, and it will try to supply current to the load. But because the switch is physically open, so the inductor will accumulate a lot of negative charges in this side and a lot of positive charges on this side. These positive charges will accumulate here, and there is a very big voltage difference between the terminals of the 12 volt power supply. So it will be maybe 10 times, 12 times, 20 times more than 12 volts, maybe 100 volts, 50 volts. So this will cause the very big voltage spike you see in the waveform after we open the switch. So to get rid of the voltage spike or the high voltages produced by opening the switch, we will add this diode to this circuit. So you will notice that this diode is connected in a way. Its cathode is on the positive side of the source and its anode is on the other side. So it will be open circuit, reverse biased during the on state or during the switch on. So it will not do anything to the circuit, but after we open the switch, it will be conducting because it will be forward biased. So it will act like a short circuit, and the current will actually flow through this diode like this. The source will be completely disconnected. So the inductor in this case will not develop a high voltage on its terminals because the electrons which the inductor is pushing here and the positive charge he is pushing here, they have a path to neutralize here, so the current will continue flowing in the circuit through the diode. So we see now that the circuit is working better than the first time, and the diode is providing an alternative path for the current. Now opening the switch will not cause a voltage spike, and the circuit is working in a good way. Now if you see, if I continue switching the switch on and off, the voltage will be always less than 12 volt, and we achieved what we wanted. But there is a ripple on the output voltage in the red here on the oscilloscope. This ripple can be smoothened using a capacitor. So we will add a capacitor to this circuit. But before we add a capacitor to the circuit, I want to show you how the inductor reverses its polarity during the on and off time. If you look at this DC voltmeter, and after we open the circuit, if you look closely here, opening the switch will cause the inductor voltage to be negative, and it will be positive during the on time. And if you want to see it more closely, we will put 3000 Henry inductor. This is not real inductor, you will not find it in real life, but it is just for demonstration. So looking at the inductor voltage now, you will see that it will be negative while the switch is open and positive while the switch is closed. So to improve our circuit, we will add a capacitor on the load. So this capacitor will smoothen the ripple on the output voltage. So if we now try to switch on and off, you will see that the voltage is smoothened. I will try to make the switching faster, and you see now the voltage never reaches 12 volt. It is actually at levels of 5 or 6 or 7 volts, and this is because the switching frequency is very slow. I cannot manually switch at high rates. The circuit will be improved if we used high frequency switching by a pulse width modulated signal. If we reach to 1 kilohertz, 2 kilohertz, maybe 20 kilohertz, maybe 60 kilohertz sometimes, it will be better. In the next video, I will show you how we will control this switch by a pulse width modulated signal, and after that I will also produce another video to show you how to make a real circuit, a real buck converter based on Arduino. Thank you, and please don't forget to like and subscribe, and the most important, to comment on the video and share with us any ideas or questions you have.